Hey guys, welcome back to my channel. Today let's talk about unit root. 有很多同学都说小叶老师什么时候能讲一下 time series data analysis? Here you go. 今天就讲一个 based on time series data 怎么样去理解 unit root. 其实我认为非常重要，是个非常重要的概念。它更多的是一个 matrix 的概念。如果你有 multiple regression 的话，或 multiple equation 的话，它那个 root 其实它是一个 matrix with all the diagonal eigenvalues，但是我 start with the easy one，我们就用这个 AR1 model as an example，就是 first order autoregressive model，然后我给大家讲一下怎么样最直观的理解 unit root。without further ado, let's get into the video. So what is unit root anyway? Unit root. In today's video, I'm going to give you a very intuitive explanation of it. I'm going to based on AR1 model. So that is first order autoregressive model. Okay, the model look like this. Y sub t equals B0 plus B1. Y sub t minus 1 and plus error. You see the subscript t, so that means this is time series data. And unit root, meaning B1 is 1. Unit, identity. Unit, okay, is 1. So if B1 is 1, you can write the model YT equals B0 plus YT minus 1 plus error. And we assume that expected value error equals 0. So we call this random walk with a drift, right? This is a random walk. This is a model of random walk with a y-intercept with a drift. Right? We know that random walk is a very simple example of stochastic trend. So stochastic trend. Okay, that means the time series YT has a stochastic trend. In other words, this time series YT is not stationary. Okay, let's understand this unit root. Let me do this. Let's find the expected value of YT equals expected value of B0 plus expected value of B1, y sub t minus 1, plus expected value of yt. And we know this equals 0, right? And B0, B1 are constant, so B0 plus B1. Given a value of yt minus 1, so this yt minus 1, that's expected value of yt. B0 plus B1 times yt minus 1, and then that equals B0 plus B1. What is yt minus 1? So pause this video, think about it. So I can substitute yt minus 1 with b0 plus b1 y sub t minus 2 plus error, and error expected value is 0. Okay, and that equals b0 plus b1 b0 plus b1 squared yt minus 2. That makes sense? You see, this is just a recursive process, okay? Just we substitute recursively. So that's, we substitute y recursively. B0 plus B1, B0 plus B1 squared. And B2 equals B0 plus B1 y sub the previous periods, which is t minus 3. So then that equals B0 plus B1, B0 plus B1 squared, B0 plus B1 cubed, yt minus 3. And then yt minus 3, you can rewrite this, right? Substitute this recursively. Parenthesis yt minus 3, parenthesis B0 plus B1, right? Y sub t minus 4. And then that equals B0, B1, B0 plus B1 squared, B0 plus B1 cubed, B0 plus B1 to the 4th power, y sub t minus 4. Right? And then what if t approaches infinity? So, or t approaches the last period. Okay, so that's t. So there are total maybe 100 time periods or 50 years, and this t equals 50. So the data look like this. T 1, 2, 3, 4, 5, 6, 7 t. Right? Maybe t equals 100 quarters, 100 days, and this is y sub t. Right? Year 1, t1. Right? Like this. And then for the first lag value, okay, the first lag of the time series yt, which can be written as y sub t minus 1. And this is y sub 1 minus 1. When t is 1, this is 0. And when t is 2, this is 1. Okay, 3. Y sub 3, 4, 5, 6. Y sub t minus 1. This is our data. This is what our data look like, this time series data. When t approaches t, or t approaches infinity, so this, you can write this as the expected value of t equals b0 plus b1, b0 plus b1 squared, b0 plus all the way to b1 to the power of t minus 1, b0, and plus b1 to the t, and then y t minus t, which is y sub 0. Okay, so given the initial value of y, okay, so that's y0, and then you can rewrite this. Let me zoom out. So you get this expected value yt given the value of y0 equals b0 times 1 plus b1 squared plus all the way to b1 to the power t minus 1 plus b1 to the t times y0. Okay, you see this is a geometric series. You see this 1, which is b1 to the power 0 plus b1 to the power 1 plus b1 to the power 2 plus all the way to b1 to the power t minus 1. This is a geometric sequence. We have a formula to calculate the sum of this geometric sequence. So that equals b0 times 1 minus common ratio, which is b1. And the numerator is the first term, which is 1 times 1 minus common ratio, which is b1 to the power of the number of terms from 1 to t minus 1. From 0 to t minus 1 is like this. Plus b1 to the power of t and y0. So this is expected value of yt. If the time series yt is stationary, okay, stationary means, I will explain stationary. This is a very, very important concept in time series data analysis, so stationary. I will spend, I think, a lot of future videos to talk about this concept. Okay, so now let me give you a brief, very brief introduction. If this time series yt is stationary, that means it will have a, if yt is stationary, meaning that the future is like the past. In other words, you can use the historical values of y to predict the current or future values of y, because the future like the past, because this variable or the time series yt is stationary. Or in other words, you can use central limit theorem and OLS. We will talk more details about this in the future videos. Okay, so here you just need to know if yt is stationary, that means at least 2 conditions or 3 conditions must be satisfied. First one is expected value of yt equals a constant. Variance of yt is constant. And then there's no seasonality. Let's look at this first condition, or the order is not important. Let's look at the expected value of yt. So under what condition expected value of yt is constant? Expected value of yt is constant if and only if b1 absolute value less than 1. So you see, if b1 is a fraction, b1 to the power of t, as t approaches infinity, this whole term equals 0. b1 is a fraction to the power of infinity, as t approaches infinity, this term equals 1, because this term is 0. 1 minus 0 is 1. So if this is a true, and then expected value of yt just equals b0 over 1 minus b1, which is a constant. You can use the exact same way to calculate variance of this time series yt. And if and only if the absolute value b1 less than 1, can you observe the variance of the time series is constant? So if b1 absolute value less than 1, but we call this unit root process, and then this time series is stationary. Okay, if b1 equals 1 or greater than 1, this expected value of this time series variable yt does not have a constant variance and constant expected values. And then you cannot use the past to predict the future, because the future is not like the past. Stationary graphically look like this. So this is yt, this is t, like this. Right. So if this b1 equals 1, we call this unit root, right? So that also means this time series yt has a stochastic trend. Okay, in this video, I mainly want to talk about the intuition behind this unit root. Why do we always compare b1 or absolute value of b1 with 1? Where is this 1 coming from? Where this unit coming from? So it's a root because for the vector autoregressive, for the VAR vector autoregressive models, we're using multiple equations, and then this b1 is not one value, just a matrix. So we'll talk more about that in the future videos. Okay, I hope you find this video helpful. In the future videos, I will focus more on the time series data analysis. I will talk about Dickey-Fuller test and stationarity and trend breaks and other important concepts of time series data analysis. Okay, so stay tuned. I hope you find today's video helpful. As I said in the video, that I will make a whole series of time series data analysis, so stay tuned. And any questions, please let me know. Thank you so much for watching, and see you next time. Bye.